Is Earth actually a planet or not? Can dark matter be just black holes? Can a planet have a figure-8 orbit around binary stars? And in Q&A Plus, what happens if you put antimatter into a black hole? All this and more in this question show. It's time for the question show. Your questions, my answers, as always, wherever you are across my channel. If a question pops in your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get into the questions. Church discography. With over 37,000 known near-Earth asteroids, many crossing Earth's orbit, could it be argued that Earth has not cleared its orbit of other bodies and therefore does not meet the IAU definition of a planet? No. The IAU definition of a planet is somewhat arbitrary and was sort of designed to explain the 8 planets and not allow for Pluto, but Earth dominates its orbit. That if you add up all of the mass of all of the asteroids that have the potential to cross Earth's orbit, you don't have a fraction of the mass of the moon. You could form an asteroid that is maybe a few dozen kilometers across and that's it, like a big mountain. That is not like the mass of the Earth, which is like 6 times 10 to the 24 kilograms. Like it is an enormous amount of mass in the Earth. When you look at Pluto, Pluto is just one object among peers. So there's Pluto and then there's Eris. And Eris is, roughly the same size as Pluto. And then you have Haumea, and then you have Makemake. And when you add up all of the mass of all of the objects in the Kuiper Belt, Pluto is just one component of that mass. And so that's what they were aiming for. But if you have problems with the IAU definition of planet and how it de-promoted Pluto, you're in good company. Many people agree with you that that was the wrong way to set it up. And so lawyers could be busy forever litigating this. And for me, I don't care. I just don't care. Pluto is Pluto. It's its own special thing. And I don't worry about the definition of the planet. Paul Hatfield. In a binary system, would it be possible for a planet to have a figure-8 orbit around the 2 stars? No. Now, binary systems can have planets. It's just that they can't be in orbit around both of the stars. So there's a couple of scenarios where binary stars can have planets. You sort of think about like the Tatooine, right? Like whenever astronomers find a planet in a multi-star system, people are like, oh, it's Tatooine, because you think about Luke walking on the surface of Tatooine and seeing the multiple stars in the sky. So the 2 methods are, if the 2 stars are very close together, then a planet can orbit around both of the stars, because the stars essentially are orbiting around a common center of gravity in between them. And from the perspective of the planet that is farther away, it sees them as like one mass. And as long as it's far enough away, about 2 to 4 times the separation of the stars, then it can be stable. And so you just have these 2 stars going around each other, and then you have a planet, a multiple planetary system. All these planets are just going around these stars. So that's the one possibility. The other possibility is that the stars are so far apart that the planets are able to orbit around each one of the stars, and they're not getting messed up by those stars. And, we don't know if there are any planets around Alpha Centauri, but the stars in Alpha Centauri are 11 astronomical units apart. So it's, 11 times the distance from the Earth to the sun. And that's far enough, like typically beyond about 5 AU, 5 times the Earth-Sun distance, then planets can be stable around those stars. So the figure-8 is just not stable, right? Like you would get tiny changes in sort of direction as the stars are going around, the planet is going around, and your planet would either be thrown out of the system or would be gobbled up by one of the stars. It has to orbit both of them. Lucas House, can you explain the black holes and dark matter paper that came out recently? I'm not sure which black hole and dark matter paper came out recently that you're talking about. Many of them have come out. And the gist is that one of the explanations for dark matter, right, which is this seemingly invisible matter that only interacts with regular matter through mass, but not through any kind of electromagnetic interaction. There's been a bunch of possible solutions. One is there's some massive particle that we just aren't aware of, we can't see so far. Another possibility is that we just don't understand gravity at the largest scales, that it works in a different way at galactic distances than it does in regular distances. And the third possibility is that it is made of black holes, and that actually black holes fulfill all of the requirements. We can't see them, right? We can't see black holes. They have mass. We know that they have mass. and that there could be a lot of them out there. Now, it doesn't feel like there can be enough black holes if you just go with the deaths of stars, because like whatever black holes are, there would need to be 5 times as much black hole mass as there is just regular stellar mass and gas and things like that. And so you would have needed a different kind of formation mechanism. Just then stars die, you get black holes find each other, merge, that it probably would have been something that would have formed early on in the universe. And this is this idea of primordial black holes. So you would have regions of higher and lower density early on in the universe, and that would be dense enough that you would just get black holes forming naturally. And you get them at all different sizes and shapes. And, you know, this idea that black holes can explain dark matter has been around for a long time, and it just refuses to go away because it just hasn't been overturned yet. If you talk to most scientists who study dark matter, they're not going to say, oh yeah, dark matter is definitely explained by black holes, but they can't rule it out. But what they can rule out so far is black holes of varying masses. So they know that these things probably aren't like stellar mass black holes. They could be a ton of little black holes, some things with like, say, the mass of an asteroid, or they could be black holes with like 1,000 times the mass of the sun, but probably not anything in between. If there was that stuff in between, we would actually see stars flickering as black holes were passing in front of them from our perspective. We'd be seeing these gravitational microlensing that would tell us that those black holes are out there, and we don't see that. So we have to rule out that idea. But still, yeah, dark matter could be black holes. It's time to shout out our new patrons at the $5 level and above: Joseph J. Bernat, KJ Paul, Mendel Skulski, Dan Lynch, Yan S., Ashley Kirby, Lauren Trottier, William Fincher, Hefe Qwerty, and Stella Luna the Bat. Join our community at patreon.com/universe today. Clark Holt: have scientists calculated or run simulations on what a planet core remnant from a star exploding would look like through our telescopes? I often wonder what types of theorized minerals might exist. There's a lot going on in that question that I kind of need to unpack. So a planet core isn't the remnant from a star exploding. The planetary core is, I mean, I guess it kind of is, because, you know, a planetary core is made up from all of the remnant materials that were part of, you know, stars exploding, creating heavier elements in their cores through nucleosynthesis. And then that turns into metals that then are part of a protoplanetary protostellar cloud, and they become part of the planets. You know, you ask, like, can we see what they look like through our telescopes? And the incredible thing is that we actually can see planets forming in young star systems. Before, we weren't able to see this because they were shrouded in gas and dust. But infrared telescopes, infrared light is able to look through the kind of dust that obscures our view into these places. And the ALMA telescope uses radio waves, microwaves. It's able to see into these kinds of things as well. And we can now see protoplanetary systems, you know, systems that are just a few 100,000 years old, a few million years old. You can still see the rings of gas and dust left over from the initial formation. You can see planets forming inside these rings of gas and dust. And it's a revolution in what we're able to see in the formations of new planetary systems. And now we've seen almost every single example. We've seen the very first stages as tiny little knots of planets are starting to form, all the way to the point where the planets have pretty much fully formed. The star is starting to ignite and blast out radiation that's clearing out all of the leftover material and everything in between. Like, we're at dozens, if not hundreds, of protoplanetary systems seen in ALMA. It's really amazing. Andy Fry Wireless: if the edge of the observable universe is the same in all directions, would that mean that we are the center of the universe? Well, let me give you an analogy, okay? You go out into a dense fog, right? It's very foggy, but there's like enough light that you can see. And you are seeing around you, you can see your hands, you can see the ground in front of you, and you can see objects that are relatively close. And then after a little while, everything is lost in the fog. And so you are in the center of your own observable fogiverse. But are you at the center of the fogiverse? No. There are other people, and they are having their own fogiverses. And you are seeing your fogiverse, they're seeing their fogiverse, and that you could have overlapping fogiverses if they get close enough to you that you can actually see them. And so it's the same thing with the observable universe. We all have our own observable universe. and it is unique. So where I am here in Canada, I have an observable universe that I can see, and that is different from the universe that you can see. Even though you're probably several thousand kilometers away from me, and so I may see things in the universe a few nanoseconds before you do in one direction, and you'll see things in the universe a little farther and a little sooner than I will on the other side. And so, no, the whole point about this is that no matter where you go, you will see kind of the same thing. You will see planets around you, stars, galaxies, and then in the end, you will see the cosmic microwave background radiation, which is the edge of the observable universe. No matter where you go, if you instantly teleported 10 billion light years away, you would see kind of the same thing. You'd see stars, you'd see galaxies, and you'd see the edge of the observable universe. Ian Cudmore. Fraser, are other publishers, regardless of subject matter, that are doing similar work to Universe today that you can recommend? Independent publishers that do all their own sourcing for articles, etc. Like, regardless of, like, I don't know sort of what people are doing in other subject matters. I'm fairly familiar with the space journalism industry, and so there are fairly large publishers that have divisions. So for example, space.com, which is, probably the most popular space and astronomy news website, they're owned by a company out of the UK called Future, I think. And then you have, say, Ars Technica. I think they're part of Condé Nast, and so they do great coverage. To find independent voices, you typically have to look for journalists that have separated from a larger masthead. A lot of people are doing newsletters, space-related newsletters, but also just other topics. You find people on Substack, things like that. And they're doing very well for themselves. If you've built up a following, where people trust your journalism, trust your work, you show up on a regular basis and you help explain things and do real reporting, you can really build a following. And so, unfortunately, I don't have names that sort of pop up. I'm a huge fan of Zvi Moskowitz, who's someone who's reporting on AI work, and he has a Substack, but there's like a lot of other just independent journalists. And I'm sure people who are watching this have a bunch of email newsletters that you, in some cases, are subscribed to and actually pay. Phil Plait actually has, the Bad Astronomer, he has a newsletter that he sends out on a regular basis, and I think you can support him. So that's a good example. So I think, we're in this really difficult, uncomfortable transition between the old way where journalists would be gathered together under the masthead of a larger organization, and then they would have a certain amount of protection. They'd be part of a union. They would be able to take a salary. And the newspaper was a very stable revenue source that you had people who were buying your newspaper in the city, and you were the paper of record. And so people would be buying your newspaper. And then advertisers knew the only way to get in front of people was to place ads in your newspaper. And so it was a very established, well understood system. And then that's all been destroyed. The internet destroyed the newspaper. And now the AI and just other forces are destroying just web news in general. And it looks like the thing that's coming out the other side of that is individual journalists who can build up enough of a following. They can essentially pull a salary from the combined donations of the people who watch them and trust them. And that's not bad, actually. It's hard. There aren't a lot of entry-level jobs anymore in this. You kind of have to do it in your free time to build up respect and experience and stuff. But it's kind of a cool system that you can just start writing, start doing work, start revealing information and gain a following. And then it just turns into a career, and you have no gatekeepers. There's no editor. You don't have to have these conversations with people. But there are a lot of downsides as well, which is that if you don't feel like it, right? If there's business issues that you have to deal with, you don't have any support on that front as well. So, yeah. Did you know that you can watch the same video with no ads and get a bonus question over on Patreon completely for free? We call it Q&A Plus. And this week's bonus question: what happens if you put antimatter into a black hole? And I'll put a link in the show notes. All right, those are all the questions that we had this episode. Thank everyone who put your questions into the YouTube comments, everybody who joined me for the live show. The next live show is going to be on Monday, February 23rd at 5 p.m. Pacific time. So if you want to watch the show live and ask your questions, come and join me there and then. Now, I'm going to do a bit of a rant about human spaceflight and how NASA might not have astronauts be able to go to space stations soon. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Pedretti, Bear Lake Roofing, Brian Bodie, Caradon, Chuck Hawkins, Commander Baylock, Darkfinger, David Giltonen, David Matz, Evan Pro, Greg Feely, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Marcel Switz, Michael Purcell, Nordspace, OneStepForAnimals.org, Paul Beck, Renkaidu, Richard Williams, Sean Sargent, Stephen Farley Munley, Team 49, Telescopes Canada, Wolfgang Klotz, and Zelda Borg Galactic Defender, who support us at the Master of the Universe level, and all our patrons. All your support means the universe to us. So whoever controls the spice controls the universe, and we give the power of the spice to you, the audience, to choose rants for me to go into if I need to. This one comes from patron Havato Lezi. Do you think that if ISS gets deorbited, and assuming there's no private station that goes up, and the only station left will be the Chinese, will the USA send astronauts to that station, or will they become spaceless? So this is like a question, but it's really kind of a rant, which I'm about to go into, which is that right now, the state of human space exploration for the world is that we have two space stations. We have the International Space Station, which is crewed by folks from NASA and the Russian Space Agency, but also various partner space agencies. There have been Canadians on board, people from Japan, people from Europe, UK. Just no shortage of people have been able to fly up to the International Space Station. And then you have the Chinese Space Station, which, in addition to regular visits by Chinese astronauts, has, started to open up to other nations as well. And so where we stand right now is that the International Space Station is due for deorbiting at the end of the decade, probably 2030 or so. Like, unless something happens that's going to extend its lifetime, we're going to see the station come down. And we're also seeing that the Russian Space Agency is threatening to detach from the International Space Station. And there are plans from various companies to launch their own space stations, their own private space stations. VAST is the one that is probably the farthest along, but there are other companies that are saying that they might do this as well. But always, private space exploration is a very expensive, very dangerous business model. And we've seen a lot of companies that have said they're going to try and do private space exploration or build a private station and then ultimately run out of money. So we'll see, but we could very much enter this world where 2030 rolls around, the International Space Station is deorbited. There is no plan for anything comes after that. For whatever reason, the Deep Space Gateway has been pushed back or even scuttled. And so the US has no place to go. They haven't got their moon bases. They don't have the station. There's no need for human spaceflight, not only for the US, but Russia and really the rest of the world, except for the Chinese. And so the Chinese are bringing on partnership countries, but there are laws prohibiting various nations, and especially the US, from being able to partner up with Chinese aerospace firms. And this is a law from the United States. And so I don't know what's going to happen. If nations do step up, maybe we could see maybe an Indian space station, and then you probably wouldn't have those same kinds of regulations. So maybe you could have American astronauts staying on board an Indian space station. There could be a private space station, so they would go that way. But if it doesn't happen, then it's kind of no place for them to go. The Chinese will be the only game in town for humans orbiting around the Earth and performing those kinds of experiments, as well as the partnership nations that they have brought on board. But in many cases, the partnership nations that they're bringing on board are the nations that have not been able to send astronauts as part of the International Space Station. So it's kind of like a different group of people. So it's kind of tricky, and I think it's going to catch people by surprise. If there is no plans and if nobody's able to make a private space station, you'll end up with no place. And suddenly a big chunk of the world will go, wait a minute, we can't send humans to space? What's that about? So I suspect that we might get to this place, but we'll see what happens. There's a lot going on and the future is unclear. All right, we'll see you next time.